Welcome back, everyone. This is Professor Herring. In this video, we're going to talk about exceptions to the octet rule, why they occur, and the different types of exceptions that there are. Let's begin. There are three main exceptions to the octet rule that you need to be familiar with. The first is molecules that have odd numbers of electrons. The second is molecules that have less than an octet on a central atom. And the third is molecules that have more than an octet on an essential atom. Let's look at these one by one. First is odd numbers of electrons. And substances with odd numbers of electrons are often called radicals or free radicals. You can find these in molecules that are produced from car exhaust, nitrogen monoxide, nitrogen dioxide, dinitrogen tetroxide. You can also find these in the human body. The body has multiple processes that break molecular oxygen, O2, in half and split it up into oxygen with a single extra electron. These are caused in general by incomplete combustion, which is where you get them from the car exhaust. This happens by radiation. This can occur, radiation from the sun can cause formation of radicals, or harmful substances. You can find radical producing substances within fried food, alcohol, and tobacco, and then even within normal biological processes. As I mentioned above, the oxygen radical is formed millions and millions of times by your body. These molecules, because they have odd numbers of electrons, are never satisfied. They don't have a complete octet. They either have too many or too few. Therefore, they're very reactive, very unstable, and it turns out that that's actually very dangerous to us. Because what happens is that these molecules will come and they will rip off electrons from other molecules, other parts of our bodies, and that will cause a chain reaction where these radicals rip off electrons, disrupting the structure and the stability of a molecule, and that process continues until you get two radicals that collide together. Or vitamins. Vitamins within the human body, in any case, are what are called antioxidants, and they help to protect us from radicals, among other things. And while they can't prevent all kinds of damage from radicals, this is part of why they're an essential part of our diet. The second class of exceptions to the octet rule are hypovalent compounds. These are when you have fewer than 8 valence electrons on your elements. These are very rare. You can only really get these in the laboratory under very low pressures. And so when you look at molecules that are hypovalent, they're also very, very reactive. Some examples that you might encounter are beryllium hydride, boron hydride, boron fluoride. And what you'll notice is that the central atom in all of these cases are small elements that are on just at the beginning of the periodic table, and they don't come in with very many valence electrons. And therefore, they just don't have enough to go around. And so these molecules are very unstable. If they are produced, then they very quickly react with other elements, other molecules that have excess electrons. The third category is much more common for what you'll see in Chem 110, and this is hypervalent compounds. These are compounds with an expanded octet. As I said, these are much more common, and there's two main criteria that you need in order for it to occur. First is that the central atom must be in the third period or below. And the reason for this is because elements that are in the third period or below are much larger than the second or first period, and therefore they can form more than 4 bonds. But in order for this to happen, the elements that they are bound to must be small and electronegative. And so in this example, or these examples of hypervalent compounds, you'll notice that the elements on the exterior are all small. They're all very electronegative. Chlorines, fluorines, oxygens. That's just about it in terms of what you could get. You cannot, the exterior cannot be things like iodine, bromine. However, these could be in the interior. They could be in the central position. And you'll even notice that noble gases, you can get to form bonds when in these types of scenarios. In all of these cases, the central atom has too many electrons than what we would normally think. Okay? But the exterior atoms are all satisfied with their octet. You can get scenarios where we have extra electrons due to bonds or due to lone pairs. All right, let's do one example here. For which of the following molecules is it not possible to draw a Lewis structure that follows the octet rule? In other words, which of these has to violate the octet rule? So the way you would do this is by drawing out the Lewis structure for each. Remember, the first rule of drawing out Lewis structures is to count up the number of valence electrons. In the xenon tetrafluoride, there are 36. Xenon is in the 8th column, and therefore it has 8 valence electrons. The fluorine is in the 7th, and therefore they have 7 each. Then you put the least electronegative element in the center and draw single bonds between it and the outer elements, and you distribute the electrons. If, in this case, everyone is satisfied, but we've only used 32 electrons, and so we have to put the extra electrons on the central atom. If we do this process for the phosphorus trichloride and the oxygen difluoride, we see that we can draw structures that do not violate the octet rule. And in fact, oxygen cannot be hypervalent. It's too small. Phosphorus, it could have an expanded octet, but it just does not in this case. If we added on a couple extra chlorines, then that would be the case. So one last word here before we finish up with this video is, why do we need small electronegative elements to be able to have hypervalent or expanded octets? The reason for that is because what's happening is we're trying to, when we have an expanded octet, we're overloading the central atom with electrons. Remember, the electrons repel. And in order then to minimize repulsions, if we have small electronegative elements, they're going to pull the electron density towards them, away from the central atom. So the elements with high electronegativity pull the electron density from the center, which reduces electron-electron repulsions. This combined with having a large central atom will reduce the repulsions large enough that you can create a stable molecule that has an expanded octet. That's it for this video, guys. It's a short one. Thanks for watching. If you have questions, be sure to ask on Piazza, in office hours, or in recitation. Have a good day.